Hello guys, my name is Amit. So today we are going to discuss this question, evaluate division. So the question is something like that we are given rather three arrays, two-dimensional arrays. Um, One is called the equation. So let me just read it. You are given the array of variable pairs equations and array of real number values where equation I is equal to AI BI and value I represents uh, the equation AI by BI is equal to VI. Each AI or BI is string represented in the single variable. You are also given some queries, CJ, DJ. J represents the query. Return the answer to all the queries. So the question is something like this that uh, if something like this equation is given, this can be interpreted as A by B is equal to 2 and B by C is equal to 3. Let me just quickly try to. So here we can say A by B is equal to 2 and B by C is equal to 3. And then we have to find A by C. So how we are going to find A by C? Um, Either we can say it something like A is equal to 2B and B is equal to 2C, 3C, sorry. And then if you want, we just reverse it. That means uh, C is equal to B by 3. So it means A by C is equal to this divided by this, which becomes 6. Similarly, B by A um, can be got similarly as zero point 0.5 because A by B is, if A by B is 2, then B by A will be 1 by 2. And they say that if there is a query and some query that is some variable doesn't exist, then we have to return -1. Since E is not present in the equations array, so we have to return -1. Then again from A to A or any node, maybe one query, one variable is equal to the second variable, we have to return 1. And again, if there is any variable is not present, then we have to return -1. So how we are going to do this? So at first instance, it seems to be we can take some sort of hash map and then we can do it, but this is a graph-based question. So if I consider this above equation, I can say that we have some graph, something like this, that is A to B, its value is 2, then B to C, its value is 3, and we can draw the opposite graphs as well. That is, we have something as this one. B to A will be zero point 0.5 because it will be 1 by 2, and then again C to B, I'll just draw it maybe here. C to B will be 1 by 3. So with this, the question reduces to finding the path from A to C. So for example, if you want to find AC, then we'll traverse A, B, and C. So the cost of this path is 6. If we want to find BA, then we have to traverse in reverse direction. So the path of this cost is zero point 0.5, which is the answer. Then A to E, now E doesn't exist in this. So this is a directed graph, directed cyclic graph. Let me just write it down, directed cyclic graph. So since A to E doesn't exist, so we have to return -1. Then A to A, we can reach this node in 1, that is there is nothing required to traverse or something, so it's 1. And X doesn't exist at all in any, there is no node called X, so we have to return -1. So uh, And again, if we have something as BCCD here, so we can just take separate nodes, BC as a separate node and CD as a separate node which has 5.5 between it, BCCD. So if I try to look at these queries, which is, so these can be solved similarly. Uh, so for example, CDBC will be this one, that is 1 by 5, and similarly we can solve the other queries as well. So now how we are going to solve it? Basically, um, I have created this video for explaining the depth first search in a directed cyclic graph. What is the approach we are going to take, what graph data structure we are going to use to store it. Let me go to my GitHub page. So let's take this example. So costs of A to B is 6, B by A is 1 by 6, B to C is 3, and so on. And for non-existent, we have to return -1. So we'll be storing this directed graph in hash map, uh, of hash map. So we'll have a unordered map. This is a hash map where key will be string and value will be the cost, and this will be the parent node. For example, if we want to store this entry, that is A to B, so what we'll have is we'll have key as A, and then this inner hash map would be B comma 2, that is the string would be B and cost would be 2. Similarly, if we want to store this one, then we'll have key as B, and and this string, that is the key, inner key would be C and the cost would be 3. But again, B is also connected to 2, B is also connected to A. So what we'll have is we'll have another entry in the inner hash map. Inner hash map represents the nodes which are connected to a particular node. For example, I'll just explain for better clarity. For example, if we have A, B, C, and we have few other nodes connected to B, for example, D, and there is one more node connected, something as E. So what we'll have is the graph of B would be something like this. B would be the key, and it'll have the hash map inside it is it has E comma whatever the cost is 4. Then it can have C comma the cost, maybe let's take 5, and then it'll have D comma cost, let us take it 6. So this will be 5 and this will be 6, provided these are directed edges. And it will not have an entry to A because B cannot reach A, but only A can reach B. So this will be the graph for B. So now what will happen is with provided we'll iterate for every query, that is in question we'll have queries as A to C. So we'll take source as A, destination as C in this graph, and we'll try to do a depth first search. That is, we'll try to go deepest into the graph and see that if we can reach the source. And on whichever node, on whichever stack, so we'll do it using recursive functions. So on whichever stack we find that destination is equal to, we hit the destination, so we return the product, that is this cost from that function. So we have to iterate over queries. So this auto will take the query, that is this is a source, this is a target. And if source is not found, or target is not found, then we have to return -1. If source is equal to target, that is something as AA only. We are at AA, where it is something as this. So we have to push back 1. Otherwise, we have to perform depth first search. So in depth first search, let me just take this as example to explain the depth first search approach. So in depth first search, we have to take a visited hash map. So I have taken unordered set here. So this will be a visited, this will be a hash map with only keys, right? So as soon as we enter into the depth first search function, we'll mark that particular node as visited. So we'll have visited array and we'll mark. So if target is directly connected, we have to return the cost uh, similar to what I have discussed, that if we are on node B and we have a directly connected neighbor, so we have to return this cost. Otherwise, we have to check all the neighbors. For example, if B has some other neighbor, D, E, F or something, so we'll be checking all the neighbors of current node. So if neighbor, any of the neighbor, that is C, uh, or for example, if we start from A, we want to go to C and we are on B. Now the neighbor of B is A and C. So A is already in a visited list, so we'll not uh, do anything. If neighbor is in visited list, we have to continue to next neighbor, that is C here. And if it is destination, that neighbor is equal to destination, then we have to return the product of cost. So something, this is the pseudo code. We'll just look at the code in subsequent section. So let me just explain the DFS. So in DFS, we are at current, we are at target, and this is a product. So product is initially one that has to be passed. So for example, at node A, we are, that is the current is A, target is C. So we have to insert A into visited. Then is target directly connected? That is A directly connected to C? No, it is not. So it will go inside else. All neighbors of current node. So neighbor one, there is one neighbor of current node, that is B. If neighbor is in visited list, no, it is not. So we'll do depth first search product into cost. So we'll reach node B and the product would be is equal to 2 into 1. So now at B, what we'll find, we'll insert B into the visited array because B has become current and target is C only. So if target is directly connected, uh, no, it's still not. So what we'll do, we'll do traverse all the neighbors of current node. So we'll have A and C. So what we'll have is if neighbor is in visited list, A is in visited list, so we have to continue. Now we are on C, and we'll find. Sorry, I think I missed this thing because B is directly connected to C, so we'll be returning product into cost. So product in earlier was 3, and cost of this path is 3, so we'll be returning 2 into 3 here. Um, so let me just go through the code. So I have just written the code here. Let me just go through the code in Visual Studio so that we can understand it better. Control K uncomment and then let me do it Control K comment. Okay. So let me put the breakpoints so that we can understand this better. So I have taken the same example as there in on lead code, that is this one. Just give me a second. Okay, I think due to it's running, give me some time. I think it's uh, taking some time. This Visual Studio is a bit heavy, that's why. So it's still not responding. It'll take some time. I think this OBS and Visual Studio combination is making the things heavy for the system. Mm, so anyways, let's look at the code, and when this Visual Studio comes back, we'll just jump there. So um, I have created vector uh, 2D vector of string, that is 2D array of vector strings, um, and a vector array of that is values, which I have passed. And is it is it now there? Okay, now it's there, but it's still not responding. Let me just, okay, just let me wait for it a while. Okay, now it has responded. Okay, so um, okay, so this I have called calc equation from main, and this has created the graph. So now if we, so what I have done is I have taken the zeroth entry, that is A, and I have created a graph for B and the value. And similarly, I have done for everything, like every pair. So if we see here for A, we have first as A and second as B, and its value is 2.0, that is cost is 2.0. So let us just see for B, we'll understand it better. So B, the graph of B has two values in its unordered map, which is inside. So first is A, which is connected to zero point 0.5, and other is C, which is connected to 3, right? This one zero point 0.5 and this one 3. So now we are going to the queries. So um, so it just checks that if unordered map IT is equal to source. So this one will be equal to A, that is, and IT1 will be equal to C, that is the destination. So if A is not in graph or destination is not in graph, I have to push back -1. If A and C are equal, then I have to push 1, which is also not the case. Otherwise, I'll be taking a visited array. I'll be doing a depth first search on source, which will be A, and I'll be doing till target, which will be C, and product is taken as 1. So let me jump into here. Okay, so let me put a breakpoint here directly, and okay, it comes here. So now I have inserted A into visited. Then I'll find the node in the graph, because I have to go into the connected neighbors of the present node. So connected neighbors, okay, I'll just find the connected neighbors as second. So I have just found the target as C. So now I need to check all the neighbors of current node. So an order map of current is A. So I'm going through all the neighbors. So I'll check the next node, which is B, which is directly connected. I'll check that whether I have already visited this node or not. So which will be not, because I have still not visited. So it'll go into this depth first search. Let me go into this. Uh, Let me again put. So now I have gone on to B. So it will be the current node would be B, target would be C, and the product would be 2. Let us just check. 2, target is C and current node is B. So now we are here on this node. So again, we are going to check the same conditions. Um, but now if we see that since the graph of B will have C as its neighbor, right? So what we have done here is we have got B here in the first iterator, and then we are going to find uh, in the second. So if we see here in map, uh, we have B, and in second we have two nodes. So we'll find the destination C, and if we find it, we'll just return the product, right? So and we'll erase the current. So we'll return the product. Um, Product is returned, and for our one pair we have pushed back the out, so it will be 6. Similarly, we can do for all other pairs. So um, so I have just submitted this code, and this it's working fine. um, Accepted. So I'll put this code on to the GitHub, and if you find any issues in the code, just feel free to comment, or maybe ping me back. Yeah, thanks a lot. Have a good day.